All right, so these are the study questions from 4.1.6. This is an ungraded activity, but provides some really good examples for the things we talked about in lesson 4.1. So just follow along in your study guide while I go through this. It should be helpful. So the number one, it says an experimenter identifies a random sample of individuals for an experiment to test the effects of a new memory pill. He explains the purpose of the experiment to the subjects, telling them that they will take a set of pills to improve their ability to retain knowledge. He randomly assigns half the participants to receive a daily dose of the memory pill. He gives the other group a daily dose of the sugar pill, a pill with no known effect on memory improvement. He administers memory tests at the end of the experiment and finds that the memory skills improved at about the same level for each group. What might explain the results of the study? How might one improve the study to reduce the likelihood of any bias? So there's definitely bias happening in this experiment. And the reason is because before he even starts the experiment, he tells his participants that they're going to be taking a medication that's going to hopefully improve their memory, and they're going to have to take a memory test after they're done with their experiment to see if their memory had improved. So this is what we call the Hawthorne effect. The Hawthorne effect is when somebody behaves differently because they're being observed. So since they knew that they were going to be tested on memory, they automatically probably paid better attention and therefore remembered more than they would have otherwise. So, here we go. So I would write for my answer, the researcher is most likely observing the Hawthorne effect. So it's best, so in order to improve this study, he needs to redo the experiment and not tell them the purpose before starting. And of course, in some cases, it's not possible to withhold that information from participants in a study for ethical reasons. But he could probably at least just not tell them that they're going to have to take a memory test. Maybe tell them that you're going to take this pill here, and we're hoping it will improve your memory. By telling them that they are going to be tested on memory, that they're going to have to actually take a memory test, they're kind of preparing for that in a way. So any of that information that we can withhold to make this more of a blind study is going to be helpful. Okay, number 2, Professor Sisyphus conducted an experiment on the possible effects of room temperature on the speed at which a machine produces rubber snakes. He identifies 100 machines and sets up the following design. 50 machines are placed in a warm room. 30 of those machines are warm near the windows, and 20 are warm and away from the windows. 50 machines are placed in a cold room. 15 of those machines in the cold room are near windows, and 35 in the cold room are away from windows. So what are the factors in the experiment? So the factors are the different pieces of the treatment. So we can see that there is 2 factors to this experiment. There is the temperature of the room and the placement in relation to windows. Some of these machines are being placed in warm areas, and some are being placed in cold areas. Some are being placed near windows, and some are being placed away from windows. So the varying factors here are the temperature of the room, and the distance of the machines from a window. Those are the 2 factors. Part B, it says, how many treatment conditions are there in this experiment? What are the treatment conditions? How many machines are in each treatment condition? So we can actually see that there are 4 treatment conditions in this experiment. 30 machines are in a warm room near the windows. 20 machines are in a warm room away from the windows. Those are 2 different treatments. 15 machines are in a cold room near the windows, and 35 machines are in a cold room away from the windows. So those are our 4 different treatments. And I can just simply write that like this. 30 are warm and near windows. 20 are in warm and away from windows. 15 are in cold and near windows. And 35 are in cold and away from windows. Part C says, what is the response variable? So the response variable in an experiment is always what we are measuring after the treatment is done. So if we go back up to the original problem, it says that he's conducting an experiment on the possible effects of room temperature on the speed at which a machine produces rubber snakes. So he's measuring, when he's done, the speed at which a machine produces rubber snakes. So the response variable is the speed at which a machine produces rubber snakes. Part 3, you're interested in whether white Americans' attitudes about prejudice towards African Americans change after they learn more about the history of African Americans. You identify a diverse sample of whites that contains men and women of varying ages, incomes, religions, and levels of education. You decide to use a documentary as a way of teaching individuals more about the history of the African American experience. Recall that there are 2 different ways of conducting a matched pairs experiment. Describe in detail how you'd use each type of matched pairs experiment to examine your hypothesis on attitudes and prejudice. So remember, there are 2 ways that we can do a matched pairs experiment. They want us to set up an experimental design for both versions. One way we can do a matched pairs experiment is to take a set of subjects that are going to participate in the experiment and match them up into pairs such that they have similar characteristics. And we want those characteristics to be things that might actually change their answers for the response variable. So I would want to take my group of however many people that I have, and for every person, I would want to find somebody who has a similar gender, because they said they have men and women, similar age, similar income, similar religion, and similar level of education. All of those, I think, would be a lurking variable for this situation. So if we can use matched pairs to isolate those lurking variables, it's going to improve the results of our experiment. Men versus women, it might be possible that men could be more prejudiced than women. Varying ages, older people tend to be more prejudiced. Incomes, more wealthy people could be more prejudiced. Different religions are more prejudiced. People with lower levels of education have more prejudice towards African Americans. So those are all definitely some factors we need to take into account. So starting with that, so we would say we would want to, from our set of subjects, we would want to match them up into pairs such that each pair has similar gender, age, income, religion, and level of education. And I'm using those attributes because those are what is listed in my problem. I know I have a typo here. Here's education. So they also College Board really likes you to put specifics into these problems. So I would say, like, specifically, if I had 100 people, I would make 50 of these pairs. The next thing, of course, is that we're going to conduct the experiment. They want the details of the experiment, even though it's in the problem. So for each pair, one individual would be in the control group, and the other individual would be in the treatment group. And now we need to describe what the treatment and what the control group consists of. So the individuals, the subjects in the control group, would receive no treatment. There's not really a placebo needed here. And would be surveyed on their prejudice towards African Americans. The treatment group is going to view a documentary about the history of African Americans first. And then, of course, we want to look at their gain score. So we're going to compare the scores from these surveys between the matched pairs. For the second type of matched pairs experiment, we're going to do something very similar, but with the other type of matched pairs experiment that we can do, we actually match everyone to themselves, giving them a pre-test and a post-test before and after treatment. And then our gain score compares each person's post-test score to their pre-test score. So I wrote here, all subjects will complete a pre-assessment to determine their level of prejudice. This will act as the control group. Then all subjects will view a documentary and will be assessed again. We then compare the pre-assessment scores to the post-assessment scores, which is how we get our gain score. Anytime we do a matched pairs experiment, our response variable is actually a gain score, how we compare the control group to the response group within each matched pair. Okay, part 4. A botanist is interested in the effects of a new plant nutrient on the brightness of the colors of a particular type of tulips. She believes the brightness of colors will improve if she uses the nutrient X4T5 rather than the old nutrient X3Y8. She also wants to make sure that the effect of the nutrient is after controlling for 2 possible lurking variables: location of garden, indoor greenhouse, or outdoor farm, and the acidity of the soil, high, moderate, or low. She's identified 60 indoor and 60 outdoor locations to conduct an experiment on the effects of these factors of the response variable. The first question, what are the factors? What are the levels of these factors? So there's actually 3 factors in this experiment. The factor she's interested in is the actual nutrient. There's 2 different nutrients that she wants to compare, a new nutrient and an old nutrient. Other factors that she's aware of are actually lurking variables here. Those are the location of the garden and the acidity of the soil. So we have 3 factors. Then in part B, it asks, what is the response variable? Or actually, going back to part A, we also need to list the levels of these factors. So for the nutrient factor, there's 2 levels. There's X4T5 and X3Y8. Remember, levels are variations of factors. For our location of garden, we have 2 levels as well, indoor greenhouses and outdoor farms. And for acidity of soil, we have 3 levels, high, moderate, and low. So I add those levels to my answer here in part A. So part B now, what is the response variable? So the response variable is what are we measuring after the experiment? So let's see, she's identified 60, So a botanist is interested in the effects of the new plants, how it affects brightness. How does it affect brightness of the colors? So I'm not sure exactly how she's going to measure that, but the response variable is the brightness of the colors. After those nutrients, of course, are introduced. So part C, create an experimental design that measures the effect of the plant nutrient on color brightness. Controlling for garden locations, soil acidity, identify the treatment conditions, and if possible, assign the number of units into each condition. Okay, so it's important here to keep in mind what we have available. It says in the bottom here, she has identified 60 indoor and 60 outdoor locations to conduct an experiment on the effects of these factors on the response variable. We also have a lot of different treatment conditions here. Because there's three factors with 2 and 3 different levels each, we actually have a possible of 12 different treatment conditions here. They could get the new nutrient, be indoors and have high acidity. They could get the new nutrient, be indoors and have moderate acidity. They could have the new nutrient, be indoors and have low acidity. Same thing for the old nutrient, same thing for being outdoors. Altogether, there are 12 possible treatment conditions in this experiment. So if we have 12 different treatments and we have 120 locations, we can hopefully put 10 different units within each of these treatment locations. Okay, so again, there's 12 treatment conditions. If you consider their nutrient, their location, and their acidity can all vary. There's 12. I'll write those down. So here are the 12 different treatment conditions we can get there. So again, with only 60 indoor locations and 60 outdoor locations, the best we can hope for is to get 10 total for each of these treatment conditions, 10 within each one of those. And of course, we want to randomly assign our tulip bulbs to those treatment conditions within those 120 different locations that she has secured. So my total experimental design is this. The researcher needs to obtain 120 tulip bulbs and randomly assign them to one of the 12 treatment conditions listed above for the total of 10 bulbs in each treatment group. After the treatment is complete, the researcher will measure each tulip's color brightness. So the main thing here is that these bulbs are being randomly assigned. Random assignment in any kind of experiment is a key factor of a good experimental design. We always want to have random assignment. So moving on to number 5, you're a scientist. You've conducted a double-blind replication experiment examining the effects of factor A on response variable B, blocking for gender. Explain what you've done in simpler terms to someone who knows nothing about experimental design. So we need to explain all of these vocabulary terms here. So this is a great vocab question. So let's see, a double-blind replication experiment. So first of all, double-blind means that not only do the subjects not know what's happening, but neither do the researchers. Replication means that we're going to perform this experiment over and over and over again, either with new subjects or under different conditions. And blocking for gender means that I've previously separated my subjects into male and female groups to account for that being a lurking variable. Gender must be something that would affect our variable B. And then, of course, when we're all done, we record the results for the variable B.